Assalamu alaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. So we have come to the end of this chapter. This is the last video in this chapter. So we have few trigonometric identities. Okay, you need to memorize them. So there are three identities actually. So the first one is sine square theta plus cos square theta is always equals to 1. Okay. Another one is 1 plus tan square theta is equals to secant square theta, and 1 plus cot square theta is equals to cosecant square theta. Okay, so you need to remember, memorize these three. So these are called as trigonometric identities, or sometimes they are even called as Pythagorean identities. Okay, because these are derived from Pythagoras theorem. Okay, Pythagorean identities. Alright, now also we know that tan theta could be written as sine theta by cos theta. Okay, see, sine theta is opposite by hypotenuse and cos theta is adjacent by hypotenuse. So if I write tan theta as opposite over sine over cos, this is what I'll be writing, right? So opposite over hypotenuse multiplied by the adjacent over hypotenuse, flips. It gets reciprocated. So you see, the hypotenuse gets cancelled and you're getting opposite over adjacent, which is actually tan theta. Okay, so tan theta could be written as sine theta over cos theta, and similarly cos theta could be written as cot theta could be written as cos theta by sine theta. Okay, so now this whole exercise is based on proving trigonometric ratios and trigonometric identities. Now here you see the first question says express trigonometric ratios sine A, secant A, tan A in terms of cot A. So everything has to be written as something, sine A is equals to something of cot A. Okay, secant A is equals to something of cot A, and so on. Okay, so you know that. So since they are asking you to write it in terms of cot A, we will write the trigonometric identity which involves cot. That is the third identity. Okay, so 1 plus cot square A is equals to cosecant square A is the third identity. So 1 plus cot square A is equals to, and you know that cosecant is actually 1 by sine. So it becomes 1 by sine square A. So now I want what is sine, right? I don't want 1 by sine. So I reciprocate everything. See here, this is 1 at the bottom. So sine by 1 could be written as 1 by 1 plus cot square A. I have just reciprocated it. Okay, so sine A is equals to plus or minus. See, whenever you find the square root, you will have to put a plus or minus. So plus or minus of square root of 1 plus cot square A. See, square root of 1 is going to be 1 itself, so I can just put the square root under the denominator. Okay, alright, so that is, here I am actually squaring both the sides. Alright, okay, so now this is one thing what they have asked, so that's over. Now the second one, they are asking you to write tan A, right? Secant A. So we should see which involves secant A. So I will write 1 plus tan square A is equals to secant square A. This is the second identity, right? Now 1 plus tan A is 1 by cot A, we know. So I will write 1 by cot square A, because they want everything to be written in terms of cot, right? So that's why is equals to secant square A. So that's equals to 1 cot. So I can make the denominators common. So multiply this by cot square A by cot square A. So that becomes cot square A plus 1 by cot square A. Okay, is equals to secant square A. Now secant square A is equals to, so you have to take the square root on both the sides, because I don't want secant square A, I just want secant A. So okay, I take the square root. So that gives you cot square, see, this I put plus or minus, cot square A plus 1, I put it under the root on top. At the bottom, I don't put the square, because it's square root of cot square A, it just comes out as cot A. So see, secant A is represented in terms of cot A. We don't have anything else. We have only cot and another 1 or 2 you can have. Okay, you can have numbers, but trigonometric function you should have only cot. That's the question. And tan A is 1 by cot A. That's it. Over. Okay, we don't have to do anything further. Now, the next one, question number 3. It says evaluate sine square 63 plus sine square 27 by cos square 17 plus cos square 73. So you see, you check the angles. 63 plus 27 is 90. So 27 could be written as 90 minus 63. Similarly, 17 plus 73 is 90. So 17 could be written as 90 minus 73. So let me put 63, I'll put as it is. For 27, I'll put 90 minus 63. So for this, I put 90 minus 63. Okay. So here, sine square 90 minus 63. That's what I'll put. At the bottom again, for 17, I put this 90 minus 73. And 73, I keep it as 73 itself. Okay. So now here you see, this becomes sine square 63 as it is. We know that sine square of 90 minus theta will be cos square 63. So I write this. and again at the bottom you have cos square 90 minus something, so that will turn out to be sin square 73, and cos square 73 remains as it is. And we know that according to the first identity, sin square theta plus cos square theta is equals to 1. Let the theta be anything, okay? If both of them are same, then it's going to give you 1. So here 63 sin square 63 cos square 63, it's going to give you 1, right? And 73 and 73 also gives you 1, okay? Any angle, same angle with this kind of a combination will always give you 1. So 1 is the answer. Now come to question number 5. So it says, prove the following identities where the angles involved are acute angles for which the expression are defined. So this you have to prove. So see, whenever you are proving a particular identity, you should see that the trigonometric ratio is expressed in the simplest basic form, okay? The simplest is you can write everything in terms of sine or cos, okay? Try to write everything as sine or cos theta, okay? So here they have given cosecant, so let's take the LHS alone. Cosecant theta minus cot theta the whole square. So I can write cosecant theta as 1 by sine theta, and cot theta is 1 by tan theta, or you can write it as cos theta by sine theta. See, I told you on top, right? Cot theta is cos theta over sine theta. So the whole square. Now let me, see, you can see that the sine theta, it's common on the denominator. So I can just write 1 minus cos theta, the whole thing divided by sine theta, the whole square. So I'll have to separately square both of them. 1 minus cos theta, the whole square, sine square theta. Now 1 minus cos theta the whole square means that 1 minus cos theta is multiplied twice, right? 1 minus cos theta into 1 minus cos theta. The whole thing divided by sine square theta could be written as, see, we know that sine square theta plus cos square theta is equals to 1. So sine square theta could be written as 1 minus cos square theta. So why am I doing this? Because I want everything in terms of cos. See, looking at the question, I can make out that everything in the RHS is everything is in the cos form, right? So I don't want sine sitting over there. So that is why I changed the sine into cos. So I get 1 minus cos square theta in the denominator, and it's of the form a square minus b square, right? 1 could be just written as 1 square, right? Could be just written as 1 square. So you can say a square minus b square is a plus b, a minus b. I hope you people remember the formula by now. So now this could be written as 1 minus cos theta and 1 plus cos theta, right? So that's what I have written in the denominator, and on the numerator you already have 1 minus cos theta and 1 minus cos theta 2 times. So this 1 minus cos theta and 1 minus cos theta gets cancelled, and you get 1 minus cos theta by 1 plus cos theta, and that's what is your RHS in the question. See, so it's hence proved. Okay, so this is how you should prove the identities. Okay, you just do whatever you know, you try to bring them into simple form and then solve them. Try to make it as equals to RHS. Okay, so complete this exercise 11.4 in your classwork. So we have finished this chapter up introduction to trigonometry. So see you with the new video, inshallah. Allah Hafiz.